quadratic. All right, so we'll have a straight line and a quadratic, and then they would have met at two separate places. So we're looking at having one pair of solution here, which means that we're expecting to get an x and a y value there, and an x and a y value there. If you have not yet subscribed, please subscribe to Daily Maths Concepts and hit the notification bell so that you will be the first to be notified when I drop the next video. Thank you. All right, welcome back everybody to Daily Maths Concepts. Today what we will be looking at is a January 2020 question number 8. So this question number 8, as you could see, it is a simultaneous equation, but it's a nonlinear simultaneous equation. So let's look on the difference between the linear and the nonlinear simultaneous equation. All right, so with the linear simultaneous equation, it's a case where we would have two lines meeting. And wherever those two lines meet, then that would be a coordinate, meaning a solution there for x and a solution for y. So this is when we have the linear, then we'll have one answer for the x and one answer for the y, all right? So where the two lines would have met right there would have given us a coordinate that would have been an x value and a y value. But that's not what we're doing here. What we're doing here is that we're looking at a nonlinear simultaneous, right? So in section 2 of the paper, we do get a nonlinear. So this nonlinear, what happened is we'll have a straight line as well as a quadratic. All right, so we'll have a straight line and a quadratic, and then they would have met at two separate places. So we're looking at having one pair of solution here, which means that we're expecting to get an x and a y value there, and an x and a y value there. So we're looking at two pairs of solutions. So we'll have an x and a y value there. You could say x1, y1, and then we'll have another pair like a x2 and a y2 there. So the nonlinear, which is the one that we're going to be doing now, we're expecting to get two pairs of answers. Substitute right now, I'm seeing where x, and we have x, but x is equal to 5 minus 3y. So I could definitely substitute 5 minus 3y for x. So let's look at these. Let us say this is equation 1 and this is equation 2. So I'm going to substitute the 5 minus 3y from equation 2. I'm going to do that in equation 1. So y squared plus 2y plus 11 is equal to x. But now I'm going to be putting 5 minus 3y where x is. So here it is, I've substituted. Then now I'm going to collect everything on one side because I'm solving a quadratic. So we could see y squared, I have a plus 2y. If I add 3 to both sides, 3y to both sides, I'll have 3y here plus 11. And then I'm going to subtract 5 from both sides. I'll have minus 5 on this side is equal to 0. In other words, then a lot of people might have said that we'll bring this across and change the sign, or bring this across as well and change the sign. All right, so basically we did that. Now let's simplify. I'm looking at y squared plus 5y plus 6 equal 0. So at this point, I'm having y squared plus 5y plus 6 is equal to 0. In order to solve this, I could definitely factorize these. And in factorizing these, let us say that my a is equal to 1, my b is equal to 5, and my c is equal to 6. From this, AC is 1 times 6, which is 6. I need two factors of 6 that could give me 5, which is a 3 and a 2, right? So we could multiply. So the 2 and the 3 could multiply to give me the 6. They could add to give me the 5. So I'm going to use them. So we have y squared plus 2y plus 3y plus 6, and this is equal to 0. So here it is. I'm trying to find two values for y, right? So I'm going to factorize this piece now by grouping. So y, open bracket, will have y plus 2, and then positive 3 for the next one, and then I'll get y plus 2, and this is equal to 0. So then if I refactorize again, y plus 2 is times y plus 3 is equal to 0. So at this stage, I could solve. I could say either y plus 2 is equal to 0, which means that if I subtract 2 from both sides, then y is equal to negative 2. So y is equal to negative 2, or y plus 3 is equal to 0. And if I subtract 3 from both sides, then y is equal to negative 3. So here it is. I have found two values for y. One instance, y is equal to negative 2, and the other instance, y is equal to negative 3. So what I'm going to do now, though, is to take these two values and then find the x for each. Suggesting that we're saying when, so I'm suggesting that when y is equal to negative 2, I want to substitute that value of y in x equal to 5 minus 3y. So x is going to equal to 5 minus 3 times negative 2. So 5 plus 6 is equal to 11. So basically then x is equal to 11 when y is equal to negative 2. So I have myself one pair of solution there. Let's go for the next one. Also, when y is equal to negative 3, we're still using x is equal to 5 minus 3y. So x is going to equal to 5 minus 3 times y, and y is negative 3. So we're talking about 5 plus 9, and that is 14. So x is 14 when y is equal to negative 3, and that's my second pair of answers. So that's how we go about solving our nonlinear simultaneous equation here, and that's that. All right, so let's go to the next question here. So the next question says the function f of x is defined as follows. F of x is equal to 4x squared minus 8x minus 2. Express f of x in the form a, open bracket, x plus h all squared plus k, where a, h, and k are constants. All right, so basically we're asked to complete this square. So I'm just going to drop a formula that can be used easily. H is equal to b over 2 times a. So let me just find so let us list out what is a, b, and c. So a is 4, which is the coefficient of the square of x, and b is negative 8, which is the coefficient of the x, and c is the constant value there. So h is equal to b, which is negative 8 over 2 times a, and a is 4. So then taking this further, negative 8 over 8, then h is equal to negative 1. So there it is. I found a value for h. Now let's find the other value here for k. K is equal to 4ac minus b squared all over 4a. So we're looking at 4 times a, which is 4 times c, which is negative 2, minus b squared, which is negative 8 squared, and all of this must be over 4 times a, so it's 4 times 4. All right, let's take this further. 4, 4, 16 times -2, that's -32. And this is -64 over 16. All right, so let's just put this together. 32 minus 32 minus 64. So I'm looking at -96 over 16. All right. So -96 over 16, which would give me -6. So here my K value is equal to -6. So having had these, right, for example, having had H, which is equal to -1, and K, which is equal to -6, I can now write my completed square. So my completed square, I had a 4 outside, and then X minus 1, because that's the H value, square, and then -6. So when I complete the square, that's what we got right there, right? So we were required to do that. So we can easily use a formula at times to get out that there, right there and then, all right? So the next question says, state the minimum value of f of x. When we express our quadratic in the completed square form, then this value here is our maximum or our minimum, but in this case, it's a minimum. So we'll say that state the minimum value of f of x, and this is equal to -6. Determine the equation of the axis of symmetry. All right, the axis of symmetry, just for note's sake, I could just say that, hey, the axis of symmetry, the axis of symmetry is equal to the negative of the h. All right, so the h that we had was a -1, which means that the axis of symmetry is going to be +1. So the axis of symmetry is at all times the opposite to h. Read over. The speed time graph below, not drawn to scale, shows the 3-stage journey of a car over a 40-second period, or a period of 40 seconds. All right, so we're looking at this here. So let's see what the question says. The question says, determine the acceleration of the car for each of the following stage of the journey. All right, and then they list out stage 2 and stage 3. So we want to find the acceleration in stage 2 and in stage 3. And let's go. The acceleration, all right, what we want to understand that whenever we have a speed or a velocity against time graph, the graph itself that you're looking at is actually acceleration, all right? So in other words, then I'm suggesting that this is an acceleration. This is acceleration here, and this is a form of acceleration in the, we call it retardation or deceleration. But the gradient, what we want to accept here, or just a teachable moment, that the gradient of a speed versus time, or a velocity versus time, is always the acceleration, right? So these that we're looking at here at stage 1, stage 2, stage 3, there are various types of acceleration. So this one, we have a constant acceleration. This one, the acceleration is 0. And this one, we have a constant deceleration or retardation. All right. So the question spoke to stage 2, what's the acceleration? It is 0, all right? Because acceleration is actually change in speed, all right, over time. And then we realized that at 16 seconds, our speed was 12. And at 32 seconds, our speed was still 12. So there was no change in speed. So if we want to work this out, so acceleration is equal to, it's a change in speed over a change in the time. So in this case, the change in the speed was a 12 minus a 12, because there was no change. All right, so you could see it's an horizontal line, which suggests no change in our speed. And then there was a 32 minus 16. So we're looking at 0 over 16, and that will definitely give us a 0 meters per second square as our acceleration. It's a 0 meters per second square, because definitely if your speed is not increasing or decreasing, there is no form of acceleration present. All right, stage 3. Stage 3. All right, so let's look at stage 3. All right, so we want to find the acceleration in stage 3 of the journey. All right, so if we quickly look at stage 3. So we're looking at stage 3 of the journey, the acceleration in stage 3. It's the change in the speed over time, right? So at stage 3, though, we started like this is our initial speed. All right, so we started at 12 and then we end up at 0 because we came down to 0 here. So the change would have been, so let's write up our formula, which is a change in speed over change in time. So when we talk about change in speed, we're moving from 12 here to 0. So then the final thing has to be 0 minus the 12 over the 40 minus the 32. If you think about taking the gradient, all right, that's exactly what this is, right? So in this case, we have a negative 12 over 8, all right? So we have a negative 12 over 8, and that is going to take us to what? Negative 1.5 meters per second squared. So this is the acceleration. And you notice I'll keep it negative because it tells that we're slowing down, right? And if they had used the word deceleration, then I would have to let this be a positive. But because they use the word acceleration, because naturally to accelerate would suggest to be increasing in our speed. But you could see in stage 3 that we were dropping in our speed until we became at 0. So technically, the acceleration was reducing, hence that negative number. But if the word deceleration was used, I would have to just use positive. But guess what? We were asked about the acceleration. So it's a negative 1.5 meters per second square. All right, guys. Thank you for watching. And